All right, number 7, decide whether the parafunctions graphed are inverses. Now, this is similar to what we looked at in questions 5 and 6, where we're given two functions and asked if they're inverses of each other, except now you can see no longer are we being provided the functions themselves. Instead, we're being provided their graphs, but we still have to come up with an answer whether or not these two functions are inverses. So for the purposes of number 7, let's go ahead and let this line here, this solid line, be f of x. And we'll let this solid line down here be g of x. And the line, the dotted line here in the center that's kind of cutting this graph in half is the line y equals x. And you'll often hear people refer to y equals x as a mirror. And what they're really asking you to do when they call f of y equals x a mirror is for you to visualize if this was in fact a mirror, would f of x reflect over the mirror and become g of x? If we held or put a mirror right down the center here where this dotted line is, y equals x, would the f of x line mirror reflect and become the g of x function? Now, a lot of people, especially those who are more visual, don't have any problem seeing that. I'm not quite so visual, and so sometimes that doesn't really help me. So what I like to do is I like to find 2 or 3 points on the f function. And then once I have those points, I want to see if I can find the inverse, the opposite of those points on the g function. Remember, if we have a point x, y on the f of x graph, then what we're looking for is for these 2 points to swap, meaning whatever y is, we want that to come down and become our new x. We want whatever was originally the x to come down and become the new y. And if that point is on the g of x function, then we can start to see a pattern. And so if we do this for 2 or 3 points, we can usually say with a high degree of confidence that f and g are inverses. If, however, we find even just a single point on f where the inverse, the flipped point, is not on g of x, then they're not inverses. So let's look at that a little more closely using real numbers, and I think it'll make sense here in a second. So we can see that the point right here, how about this one? This is the y-intercept on the f function, is 0, 4. So we want to find if we can determine if the point 4, 0 is on the g of x function. So let's see. Yeah, sure is, right? Right here. There is 4, 0. All right, so we see that the x and y flipped. Remember we talked about earlier, I think it was in question 4 maybe, or maybe 3, that every point, the domain of f has to be the range of g, and the range of f has to be the domain of g. So all that means is that you're swapping your x and y values. All right, let's find another point on the f function. We can see here that we get -2, 0. So if g is in fact an inverse of x, we would expect to find the point 0, -2. And indeed we do. There it is, 0, -2, right? We didn't go left or right on the x-axis, so that's 0. But we did go down 2 units on the y, -2. So 0, -2. Again, that's the flipped, it's the inverse of -2, 0. And let's go ahead and find one more. Let's use one way down here. Now, this one might be a little more difficult, only because it doesn't appear to be going through, obviously, any of the x or y axis, but we can guesstimate the point. So how about -6, -8, it looks like. So -6, -8. So again, that's on the f function, so we would expect to find the point -8, -6 on the g function. So -8 and -6, yeah, right there. So again, -8, -6. We are 3 for 3 here, we can see, and so I would say with a high degree of confidence that yes, these are inverses. So these are inverses, and again, all it means to be inverses are that the domain, meaning the x's of the f function, become the y's of the g function, and the y's of the f function become the x's of the g function. And we were able to prove that by finding 3 points on both graphs and verifying that the points, the x and y coordinates, do indeed flop. All right, so there we have it, number 7. Let's take a look at number 8.